this kid's a wizard or schizo, man.
Quantum mechanics was developed in the 1920s. It is a set of beautiful and powerful mathematical rules and ideas that explain the world of the very small. And it's a world that's very different from our everyday world made up of trillions of atoms. It's a world built on probability and chance. It's a fuzzy world. It's a world of phantoms where particles can also behave like spread out waves. If we imagine quantum mechanics or quantum physics then as the fundamental sort of foundation of reality itself, then it's not surprising that we say quantum physics underpins organic chemistry. After all, it gives us the rules that tell us how the atoms fit together to make organic molecules. Organic chemistry, scaled up in complexity, gives us molecular biology, which of course leads to life itself.
Alright. One of the 7 Hermetic principles handed down to us in the Emerald Tablets of Thoth, or the Kybalion, or Hermes Trismegistus. One of the 7 laws of nature was the fact that the universe is mental. That's what the universe is, it's consciousness. There's a lot of debate about whether or not machines can be conscious. Is humanity anything more than a biological machine? But more than that, if you take us down to the atomic level, are we anything more than what a computer is? If you take a computer down to its raw constituents, isn't it still protons, electrons, neutrons? Everything is holographic in this reality. Binary, a set of bits, ones and zeros. And if you take everything down to the lowest point, well, there really isn't a lowest point. You just hit these walls of ones and zeros. The quantum reality is a little bit different than that. The quantum reality is the reality of consciousness, where, yes, the universe is dualistic and binary with 1 and 0, just like your life is. For instance, you have the choice to unsubscribe or subscribe. That is your choice, to like or to thumbs down this video. You have one of 2 options. You either do something or you don't do it. Doesn't matter how many options you have. At any given time, you either do it or don't do it. It's binary. It's 1 and 0. That's what probability is. So a probabilistic computer that runs on a quantum network can, by using 4 different points, determine a bit. 4 different placeholders. It can be both 1 and 0. This is using the spin of the proton, or the phase shift nature of an electron, where it wants to organize itself because of its low energy state to a pole, and then you have to exert some pressure in order to make it go out of its magnetic alignment. But in that circumstance, you have to have everything separated, cooled down. You have to have it completely devoid of outside stimuli, anything that could make it so it changes its quantum state. But we've done research, humanity, over a period of years, that consciousness can change the quantum state. Whether you're observing a double slit particle experiment or a random number generator.
Now, so far, this is basically just like a classical bit. It's got 2 states, spin up and spin down, which are like the classical 1 and 0. But the funny thing about quantum objects is that they can be in both states at once. Now, when you measure the spin, it will be either up or down, but before you measure it, the electron can exist in what's called a quantum superposition, where these coefficients indicate the relative probability of finding the electron in one state or the other. Now, it's hard to imagine how this enables the incredible computing power of quantum computers without considering 2 interacting quantum bits. Hello. Hi. Now there are 4 possible states of these 2 electrons. You could think that, well, that's just like 2 bits of a classical computer, right? If you have 2 bits, you can write 00, 01, 10, 11, right? There's 4 numbers. But these are still just 2 bits of information, right? All I need to say to determine which one of the 4 numbers you have in your computer code is the value of the first bit and the value of the second bit. Here instead, quantum mechanics allows me to make superposition of each one of these 4 states. So I can write a quantum mechanical state which is perfectly legitimate, that is some coefficient times this, plus some coefficient times that, plus some coefficient times that, plus some coefficient. So to determine the state of this 2-spin system, I need to give you 4 numbers, 4 coefficients. Whereas in the classical example of the 2 bits, I only need to give you 2 bits. So this is how you understand why 2 qubits actually contain 4 bits of information. I need to give you 4 numbers to tell you the state of this system. Whereas here I only need 2.
Evolution is not something that is random. Mutations aren't random. You know how DNA mutates? The 2 strands? The 2 strands come down, they're intertwining, and there's this matrix that connects the 2 twirling strands, the latter part of the DNA. There are some places where one can jump to the other side. It does this through a sharing of subatomic particles that is identical to quantum tunneling, which is a quantum effect. In fact, there's a machine that actually produces DNA. Like it's natural to your body. It's this little tiny, fucking almost square little box that rotates around, spinning down the helix, creating DNA. It's a molecular machine that produces DNA, but it works in a way that a piece of technology works, because it is technology. It's a biological piece of technology. But if you take it far enough back, it turns into things like carbon and silica and silicone and baseness, because we all come from stardust. Whether or not we build quantum AI on planet Earth or we create another Buddha, both of them are going to be made of the same stardust. It doesn't matter if one is more enlightened than the other. It doesn't matter if one's completely evil. We're all still from the same stuff. Even if you go far enough back to the Big Bang, we're all from that explosion.
This is one of the best known phenomena in the quantum world, quantum tunneling. The box on the left shows the wave-like spread out distribution of a quantum entity, a particle, like an electron, which is not a little ball bouncing off a wall. It's a wave that has a certain probability of being able to permeate through a solid wall, like a phantom leaping through to the other side. You can see a faint smudge of light in the right-hand box. Quantum tunneling suggests that a particle can hit an impenetrable barrier and yet somehow, as though by magic, disappear from one side and reappear on the other. The nicest way of explaining it is, if you want to throw a ball over a wall, you have to give it enough energy to get over the top of the wall. In the quantum world, you don't have to throw it over the wall, you can throw it at the wall, and there's a certain non-zero probability that it'll disappear on your side and reappear on the other. But in a way, it's sort of not surprising, it's almost trivial. Say, well, of course, life ultimately must depend on quantum mechanics, but so does everything else. So does all inanimate matter, made up of trillions of atoms. Ultimately, there's a quantum level that where we have to delve into this weirdness. But in everyday life, we can forget about it, because once you put together trillions of atoms, that quantum weirdness just dissolves away. Quantum biology isn't about this. Quantum biology isn't this obvious. Of course, quantum mechanics underpins life at some molecular level. Quantum biology is about looking for the non-trivial, the counterintuitive ideas in quantum mechanics, and to see if they do indeed play an important role in describing the processes of life. Here is my perfect example of the counterintuitiveness of the quantum world. This is the quantum skier. He seems to be intact, he seems to be perfectly healthy, and yet he seems to have gone around both sides of that tree at the same time. Well, if you saw sort of tracks like that, you'd guess some sort of stunt, of course. But in the quantum world, this happens all the time. Particles can multitask. They can be in two places at once. They can do more than one thing at the same time. Particles can behave like spread out waves. It's almost like magic. Physicists and chemists have had nearly a century trying to get used to this weirdness. I don't blame the biologists for not having to or wanting to learn quantum mechanics. You see, this weirdness is very delicate, and we physicists work very hard to maintain it in our labs. We sort of cool our system down to near absolute zero. We carry out our experiments in vacuums. We try and isolate it from any external disturbance. That's very different from the warm, messy, noisy environment of a living cell. Biology itself, and you think of molecular biology, seems to have done very well in describing all the processes of life in terms of chemistry, chemical reactions. And these are reductionist, deterministic chemical reactions, showing that essentially life is made of the same stuff as everything else. And if we can forget about quantum mechanics in the macro world, then we should be able to forget about it in biology as well. Well, one man begged to differ with this idea. Erwin Schrödinger, he of Schrödinger's cat fame. He's an Austrian physicist. He was one of the founders of quantum mechanics in the 1920s. In 1944, he wrote a book called What is Life? It was tremendously influential. It influenced Francis Crick and James Watson, the discoverers of the double helix structure of DNA. To paraphrase the description in the book, he says, at the molecular level, living organisms have a certain order, a structure to them that's very different from the random thermodynamic jostling of atoms and molecules in inanimate matter of the same complexity. In fact, living matter seems to behave in its order, in its structure, just like inanimate matter, cooled down to near absolute zero, where quantum effects play a very important role. There's something special about the structure, the order inside a living cell. So Schrödinger speculated that maybe quantum mechanics plays a role in life. It's a very speculative, sort of far-reaching idea, and it didn't really go very far. But as I mentioned at the start, in the last 10 years, there have been experiments emerging showing where some of these certain phenomena in biology do seem to require quantum mechanics. And I want to share with you just a few of the exciting ones. This isn't speculation, by the way. This is, we're happy, well, happy is not the right word. We are familiar with this. We know quantum tunneling takes place all the time. In fact, it's the reason our sun shines. The particles fuse together in the sun, turning hydrogen into helium through quantum tunneling. Back in the 70s and 80s, it was discovered that quantum tunneling also takes place inside living cells. Enzymes, those workhorses of life, the catalysts of chemical reactions. Enzymes are biomolecules that speed up chemical reactions in living cells by many, many orders of magnitude. And it's always been a mystery how they do this. Well, it was discovered that one of the tricks that enzymes have evolved to use, to make use of, is by transferring subatomic particles like electrons and indeed protons from one part of a molecule to another via quantum tunneling. It's efficient, it's fast, it can disappear, a proton can disappear from one place and reappear on the other. Enzymes help this take place. This is research that's been carried out back in the 80s, particularly by a group in Berkeley, Judith Klinman. Other groups in the UK have now also confirmed that enzymes really do this.
But that's how reality works. So, believe it or not, biology and quantum physics are completely tied. It's called quantum biology. But I take it a step further, and I call this theory that I'm under the current hold of, I've been terming quantum epigenetics. We are literally recreating ourselves 50 billion times a second. We are electron clouds of probability, constantly flashing ones and zeros as we make decisions, and you can create waves in this system. The magnetic fields are not just magnetic, they're electromagnetic, they're gravitaic, and they're atomic, all combined together. Atoms can, at their smaller parts, broken apart, can be non-spatial, they can be particles or waves. Electromagnetism can influence gravity. Gravity can influence time-space and how time feels. They're all fluctuating fields. Light doesn't stay the same speed. Gravity doesn't stay the same speed, pulling you down to, linear negative acceleration, negative 9.8 meters per second squared, or whatever it is. It doesn't stay that way. Light speed, they already proved that light was faster at the beginning of the universe, right after the Big Bang. Light exploded from that faster than it currently can travel. It means that as the universe expands and entropy sets in, light loses its acceleration. If you want to look at it from a pure point, the beings that we are, mortal beings formed from carbon and DNA, we are light slowed down.
Research carried out by my group. So as I mentioned, I'm a nuclear physicist, but I've realized I've got these tools of using quantum mechanics in atomic nuclei, and so we can apply those tools in other areas as well. And one question we asked is whether quantum tunneling plays a role in mutations in DNA. Again, this is not a new idea. It goes all the way back to the early 60s. So the two strands of DNA, the double helix structure, are held together by rungs. It's like a twisted ladder. And those rungs of the ladder are hydrogen bonds, protons that act as the glue between the two strands. So if you zoom in, what they're doing is holding these large molecules, nucleotides, together. Zoom in a bit more. So this is a computer simulation. The two white balls in the middle are protons, and you can see that it's a double hydrogen bond. One prefers to sit on one side, the other on the other side of the strands. The two strands are the vertical lines going down, which you can't see. It can happen that these two protons can hop over, watch the two white balls, they can jump over to the other side. If the two strands then separate, two strands of DNA separate, leading to the process of replication, and the two protons are in the wrong positions, this can lead to a mutation. This has been known for half a century. The question is, how likely can they do that? And if they do, how do they do it? Do they jump across like the ball going over the wall, or can they quantum tunnel across even if they don't have enough energy? Early indications suggest that quantum tunneling can play a role here.
We're going to look at quantum entanglement this way. We all come from the same place. The protoatom that created all of the multiverse. So all particles are entangled. That's why consciousness doesn't depend on locality. That's how you're able to astral project as well as remote view. You can see something that's a long distance away if you're there in your spiritual form, because your spiritual form travels through entangled particles that are combined together by one massive magnetic field of creation. And it's not just magnetic, it's everything. It's these three waves working together to form this reality field. Three waves being gravity, electromagnetism, and the atomic forces, both weak and strong. Fusion and fission. artificial intelligence, if we have created it or will create it at some point, will or is a creation of humanity. If and when we die off, and if it exists after we no longer do as physical beings on Earth, then whenever it goes out into the universe, it's going to carry with it from its very beginnings a code that was created by us. Materials that formed its first brain that were dug up by humans, put together into a computer that it could then use to come to find itself in a real substantive manner, like we come to find ourselves as we grow up and age and experience life.
The final example is the most beautiful, wonderful idea. It's also still very speculative, but you know, I have to share it with you. The European robin migrates from Scandinavia down to the Mediterranean every autumn, and like a lot of other marine animals and even insects, they navigate by sensing the Earth's magnetic field. Now, the Earth's magnetic field is very, very weak. It's 100 times weaker than a fridge magnet, and yet it affects the chemistry somehow within a living organism. That's not in doubt. A German couple of ornithologists, Wolfgang and Loswinzer Wilczko, in the 1970s confirmed that indeed the robin does find its way by somehow sensing the Earth's magnetic field to give it directional information, a built-in compass. The puzzle, the mystery was, how does it do it? Well, the only theory in town, we don't know if it's the correct theory, but the only theory in town is that it does it via something called quantum entanglement. Inside the robin's retina, I kid you not, inside the robin's retina is a protein called cryptochrome, which is light sensitive. Within cryptochrome, a pair of electrons are quantum entangled. Now, quantum entanglement is when two particles are far apart and yet somehow remain in contact with each other. Even Einstein hated this idea. He called it spooky action at a distance. So if Einstein doesn't like it, then we can all be uncomfortable with it. Two quantum entangled electrons within a single molecule dance a delicate dance that is very sensitive to the direction the bird flies in the Earth's magnetic field. We don't know if it's the correct explanation, but wow, wouldn't it be exciting if quantum mechanics helps birds navigate?
Now, quantum entanglement is not only generated by conscious thought, allowing these probabilistic particles to synchronize, but you can entangle particles through a lot of different ways, by making a particle become two particles through prisms, by splitting a particle and emptying out the candy of subatomic particles inside and separating them. This is how they believe that quantum teleportation will be possible. But it's how thoughts work. See, human bodies emit light, and it's important that we emit light. These light particles are biophotons, and there's an important reason they're photons. Just like there's an important reason that's what the sun sheds through its atomic fusion. Through its multi-dimensional atomic fusion bound by gravity, by the way. But there is a reason that photons are emitted by human cells, by all living cells. These are the cells in your body flashing light are how cells communicate with each other. That's their base language. Just like the sun communicates with Earth by sharing its photons with us. We can count, measure, track the speed of those quanta of photons as they travel as particles towards Earth. We can observe them as waves if we choose to. The reason waves are important is because waves come out from a central location like ripples. Just like the sun's light comes out from a central location like ripples. And just like the sun's light hits our planet, the subatomic particle, when behaving like a wave, whenever it hits its target, it, just like the light hitting our planet, it signals to itself that it has found the correct path to get to the thing that it's looking for, and then it shifts there instantaneously. So it sends out these feelers, just like the sun's light sends out feelers for planets, because all suns and all solar systems have this area called the Goldilocks zone, where habitable planets will be most likely to contain life that is advanced, because the temperature, the climate is mild enough to support a rich, diverse biosphere, as opposed to being too far away where you'd be too cold, or too close where you'd be too hot, just like Goldilocks and the porridge. This is because suns are quantum systems that operate outside of our dimension. It's actually searching for planets with its quanta of photons, so that the photonic energy can hit the planet's surface, and with the right constituents of matter on that planet, seeds for creation, the energetic nature of the sun can stimulate positively the atmosphere against the negatively charged mass of the planet, and create an electrical differential, which would create storms and lightning, which turns on RNA, so proteins can become synthesizing DNA. Without lightning, life isn't possible. Without energy from photonic exchanges with the planet by the sun, that's how life is formed. It's almost sending us our energy and conscious fuel to create living matter. That's why there are multiple planets and multiple rings traveling in orbits around suns, because some suns are bigger than others. All suns start off as a much bigger, supermassive blue giant. Thus, the planets that are farther away, like Mars, might be habitable. Then it shrinks to a smaller yellow sun size, and planets like Earth are habitable. Then it shrinks even smaller into a red dwarf, and planets like Venus become habitable. It's literally scanning life. It's scanning solar systems with its quanta of consciously charged photons for a planet that has the natural constituent necessary for life as it descends through its natural decay as a star. So, as the star dies, sheds itself and becomes smaller, planets that used to not be habitable become habitable. Thus, if one planet has the constituents for life and is too cold or too hot, it will get its chance in the sun, so to speak. Life is not only going to be common throughout the universe. If you look at the processes of reality around us, it's pretty obvious that the universe is striving for life. It's like almost like it was an end result. Just like I believe evolution isn't just random mutations, but it has this point to it to create a being that can shed its physical form and become this pure energy, or a fourth spatial dimension creature. I believe that the universe has a purpose to it, and that is to create life, so that life can fulfill its purpose of becoming something more than life, so it can become its purpose as spiritual light beings of energy to create the universe in which it was created. Paradox. Chicken or the egg, once again, just like Alice in Humanity. The creator becomes the created becomes the creator. We are God, you are God, life works this way. Accept it or don't.
Another example of quantum mechanics in biology is quantum coherence. In one of the most important processes in biology, photosynthesis. Plants and bacteria taking sunlight and using that energy to create biomass. Quantum coherence is the idea of quantum entities multitasking. It's the quantum skier. It's an object that behaves like a wave so that it doesn't just move in one direction or the other, but can follow multiple pathways at the same time. Some years ago, the world of science was shocked when a paper was published showing experimental evidence that quantum coherence takes place inside bacteria carrying out photosynthesis. The idea is that the photon, the particle of light, the sunlight, the quantum of light, captured by a chlorophyll molecule, is then delivered to what's called the reaction center, where it can be turned into chemical energy. And in getting there, it doesn't just follow one route, it follows multiple pathways at once to optimize the most efficient way of reaching the reaction center without dissipating as waste heat. Quantum coherence taking place inside a living cell. A remarkable idea, and yet evidence is growing almost weekly with new papers coming out confirming that this does indeed take place.
Let's say you have a twin. Your twin goes off to a different country, and you're one of those special twins that has such a deep connection with your twin that you feel each other's emotions. You stub your toe in your home country and your twin feels it a continent away instantaneously, because there is an emotional entanglement because of consciousness affecting the resonance of your atomic field. That's how a twin is able to experience something non-locally. Now let's say that conscious shift that allowed you to communicate over vast distances is something that's not only inherent in twins, but anybody who has a close connection with somebody else. Have you ever gotten a text from someone you're really close with and you instantly felt that something was wrong, even though it was a couple words? There's something off.
A feeling of solidity. No, that's why things feel solid. Not because they are made of solid stuff, but because the charges are interacting. Okay, so this energy that is the atomic world flashes in and out of existence 50 billion times a second, and each time it comes back, it reconstructs itself in the shape that we see with our eyes. And it does so because it obeys the information field. Energy organizes itself around information fields such as human intent and so on. And so we have a new definition of physicality as something that is mostly space, something that is pulsing in and out of existence rapidly, but something that is organized to maintain a particular shape and feeling based on information. DNA science tells us that DNA has the ability to structure and order light, to order and structure energy. DNA is an information field that can manipulate energy. And so now we can redefine what we think of as the physical body. The body is a quantum field, flashing in and out of multi-dimensional existence so rapidly that we don't even notice that it's happening. It flashes 50 billion times per second, which means you or your body has 50 billion chances per second to change. Meaning if you change the information field, the next flash will rearrange itself according to the new information. DNA is that information, and it structures the energy into the thing that you now call the body. But it is extremely fluid. It's fluid because the information is fluid. Basically, DNA is asking human intent the following question. Boss, shall we do the same or different? It asks this question 50 billion times per second. Usually, the human answers, well, let's do the same. And so, the same body is reconstructed. The same physical experiences, and the world seems so solid and unchangeable because of that answer. Not because it is that way, but because the information field hasn't changed. But the instant the human answers, hey, let's do it different this time, it changes the field. It changes everything. That is the miraculous power of the human. Consciousness has physics. And that, ladies and gentlemen, is the amazing world of DNA, of who you are, grand you are, loved you are, immensely bestowed and endowed with powers beyond your imagination you are.
It's still speculative, but I believe it's built on solid science. I also think that in the coming decade or so, we're going to start to see that actually it pervades life, that life has evolved tricks that utilize the quantum world.
Art, in a world gone mad, only a lunatic is truly insane.
Please believe me! Please believe me!